proof is just another way to write a proof. It kind of follows like the way that your thinking flows instead of having it in two columns. So they split off these two givens, and so they have given that M is parallel to K, we know that, and they put that in one column. And then we know that 3 is congruent to 1, and they put that over here in this other column. Those are both givens, that's why I know those. So anytime you have angles or lines that are parallel, it will result in corresponding alternate interior, alternate exterior, same side interior angles somehow to be useful for me. So if M is parallel to K, if I look at those and if I just use the green lines, M is parallel to K, and then I use transversal G, then what I know is that angle 2 is congruent to angle 3. Because if lines are parallel, which I said they are, then alternate interior angles are congruent. So because I know the lines are parallel, then I can say the angles are congruent. So over here I have this set of angles are congruent, and I have this set of angles are congruent. Now since I know that, then I can say that angle 2 is congruent to angle 1. So those two result in, that's why these arrows come, these lines come down, they result in 2 is congruent to 1 because of the transitive property. Now that I know that 2 is congruent to 1, I've labeled that on my picture so that I can see it. Now I look and I go, now I know about those angles. Those angles are alternate interior angles. And if alternate interior angles are congruent, I know that lines are parallel. Now, that's what I was trying to prove all along. So because 2 is congruent to 1, I can say that F is parallel to G. Because if alternate interior angles are congruent, lines are parallel. The order that you say it in matters. Okay, this leads to this. Notice what comes first. Angles, it starts with angles. This one was parallel, it starts with lines parallel. It matters the order that they're in, and on a test you would be given both of them as an option. If lines parallel, if alternate interior angles, you would need to know which one to use, and it depends on what you have first as to which one you use. Okay, so that's one example of a flow proof. Let's look at another one. Here's angle 1 is congruent to angle 2. Now, there's a short way to do this. We can solve this really fast. If 1 is congruent to 2, those are alternate exterior angles, right? And if alternate exterior angles are congruent, then those lines are parallel. Done with the problem. But I want you to follow these steps. Okay, so we're going to do this a different way, which you can. We're going to do this a different way. We're going to say 1 is congruent to 2 because I was given. I know that. Vertical angles, if I look at this picture, vertical angles are congruent. We just talked about that. Vertical angles are congruent. That means that angle 2 is congruent to angle 3. Now these two ideas come together and allow me to use the transitive property. The transitive property allows me to take out that middleman, that angle 2 middleman, and say that angle 1 is congruent to angle 3. Okay, now if angle 1 is congruent to angle 3, now I'm looking at those. Those are corresponding angles, and I know that if corresponding angles are congruent, then lines are parallel. In this case, there's only one set of lines. M is parallel to P. Notice again, I had angles, so I mentioned angles first. Angles will usually result in parallel lines. Parallel lines will result in angles. Okay, so that is what a flow proof looks like. Let's look at some more two-column proofs that have to do with this. They're going to look similar to what we did the other day, only the other day we started knowing that the lines were parallel and we ended up proving things about the angles. Today we're going to start with the angles, knowing things about the angles, and end up by proving the lines are parallel. So the first thing that we say is our given. That's always our first step. Angle 8 is supplementary to angle 3. I know that because it was given. Now, you need to write proofs as though you're teaching somebody who doesn't know anything about geometry. So the first thing they're going to ask is, well, what does that mean? What does supplementary mean? So angle 8 plus angle 3 is 180 because that's the definition of supplementary. Angles that add together to give you 180. Now from there, I've given you a hint as the direction that I want you to go. There are lots of things I can say, okay? But right now I don't know anything about any lines. All I can do is talk about the angles. So I bring up that 8 and 7 are equal to 180, okay? That's because they are a linear pair. Now, because of that, remember where I'm trying to go is I've done 8 and 3. 8 and 3 equal 180, and 7 and 3 equal 180. I'm trying to get to something else that I know. Now, the one thing that's in the middle is that 7, right? So somewhere I'm going to be using that 7. So the transitive property is taking out the middleman, right? So we need to take out the middleman. Now, the middleman is not actually angle 8. That's what everybody's been wanting to take out all day. And we're going to do that, but not with the transitive property. Okay? What we're going to take out is this equals to 180. Now, this is not the only way to do this. We could have used congruent supplements, right? If these two angles, if A plus C are 180 and B plus C is 180, then A is equal to B. We could have used that here, but because of the way this is lined up with fill in the blanks, we're going to follow this logic instead. So we're going to say then that angle 8 plus angle 3 is equal to angle 8 plus angle 7. That's taking out that 180-degree middleman. Now when I look at this, I notice that there's an 8 on both sides. Well, if I subtract it away, then I'm left with angle 3 is equal to angle 7. Now, my whole goal was to get down to knowing something about alternate interior, alternate exterior, same side interior, or corresponding angles. So I look at that and I go, okay, well, 3 and 7, those are corresponding. So if corresponding angles are congruent, now I know that 3 is congruent to 7. If 3 is congruent to 7, then that means that L is parallel to N. Because if corresponding angles are congruent, then lines are parallel. Has to be in that order. I started knowing about the angles, and then I talked about the lines. Okay? Number 4, if G is parallel to H and 1 is congruent to 2, again, those are not any of the 4 angle pairs that prove that lines are parallel. The first thing that I have to say is G is parallel to H and angle 1 is congruent to angle 2. Now this is not the only way to write it. You can split those two givens up into 2 separate steps if you want to. But we'll just write it as one step today. Now we need to do something with this. G is parallel to H. If I look at G is parallel to H, the only thing that I have is I can say that 1 is congruent to 3. And I can say that because if lines are parallel, which G is parallel to H, then corresponding angles 1 and 3 have to be congruent. So now I know that 1 is congruent to 3. Now your impulse is going to go straight to this. You'll say angle 2 is congruent to angle 3, but you'll have the wrong reason. You'll say something about alternate exterior angles here. And they are alternate exterior angles, but that's not why I know that 2 is congruent to 3. I know that 2 is congruent to 3 because of the transitive property. Not because they're alternate interior angles. Don't get ahead of yourself. Okay, I know that 2 is congruent to 3 because if 1 is congruent to 2 and 1 is congruent to 3, then 2 is congruent to 3 with the transitive property. Okay, from there, now I can say, oh wait, look, those are alternate exterior angles. If alternate exterior angles are congruent, then the lines are parallel. So then I can say, oh, the lines are parallel because those alternate exterior angles were congruent. That means that the lines have to be parallel. Okay, so while you work on the next one, I'm going to write it, but I want you to write. I want you to look at it. I want you to write it and see if you can do it on your own. And yours is going to look different than mine, but don't panic. Now, I wrote mine a little bit differently, and it's okay if you don't have this many steps. I expect you would probably have 4 steps because probably you combined these 2 steps, and that is perfectly okay. But I also wanted you to see that it's okay to write it a little bit differently because this is, you're explaining your thought process, your thinking. Okay? And so I want you to see that you don't have to write it the same way if that's not how you think. I tend to like to use each piece. So there's that piece that N parallel to M, those 2 lines are parallel, and then there's this other piece of information that 1 is congruent to 2. And I like to use each piece of the given separately. And so I tend to write my proofs that way because I figure I'm going to write it and then I'm going to use it so that I can get what I need. So N is parallel to M has to lead me to 1 is congruent to 3 because if lines are parallel, alternate interior angles are congruent. Then I can use the angle 1 is congruent to angle 2 piece. It doesn't lead me anywhere yet, but those 2 steps together, these 2 steps right here together lead me to the transitive property that 2 is congruent to 3. Again, you're going to probably want to put that if alternate interior angles answer or reason on step 4, because you're going to look at them and go, oh, those are alternate interior angles. But that's not why I can say 2 is congruent to 3. Okay, I say 2 is congruent to 3 because of the transitive property. So we kind of use it like this. These 2 steps here lead me to the transitive property that causes me to say this. Okay, then on the same lines, 2 being congruent to 3 leads me to say this, which causes me to know this. So that's kind of how we use our reasons to get to. We think this reason, that's why a flow proof sometimes makes more sense to people, because they think the reason, then they write what they know. So instead of writing what they know and then stating why, they think this is what I know, or this is why I know the next step should be this. So flow proofs can work for you in that way. All right, this last one, G is parallel to H. And yours may be wrong. If your notes are wrong, it's 1 and 4 are supplementary, not 1 and 2. So fix your notes. If you're printed in here, then yours says 1 and 2 instead of 1 and 4. Okay? So the first statement, I'll go back to putting all of my givens in one step. But angle 1 and angle 4 are supplementary. Okay? So I'll say it all in one step instead of 2. So I look at that, angle 1 and angle 4 are supplementary. What does that mean? That means they equal 180, so I need to say that. Angle 1 plus angle 4 is equal to 180. That's what supplementary means. Now keep thinking about where we're trying to go. I'm trying to prove that P is parallel to R. So I've got 1 and 4. I need to tie something to 4. Okay, I can't tie 4. Now, 3 and 4 are alternate interior angles, right? But 1 and 3 don't have a relationship on those 2 parallel lines. So I can't use 1 and 3. I need to use 1 and 2 because they're alternate interior angles. So the next statement then would say, angle 1 is congruent to angle 2. I know that because if the lines are parallel, which I said G is parallel to H, if lines are parallel, then alternate interior angles are congruent. That's 1 and 2. So that came from this. This led me to this, which caused me to say that. So now I know that 1 is congruent to 2. Well, to get where I'm trying to go, which is that those lines are parallel, 2 and 4 need to be what? Supplementary. They need to be supplementary, right? They're same side interior angles. In order for P to be parallel to R, I need for 2 and 4 to be supplementary. Well, look at what I have. I have that 1 plus 4 is 180, and I have that 1 is the same as 2. Well, all I have to do is replace this 1 right here with that 2, because the substitution property says that I can do that. So now I have that angle 2 plus angle 4 is equal to 180. Okay, that's the substitution property. I substituted in a 2 for an angle 1. Now, this step would be the step that you would miss. Angle 2 and angle 4 are supplementary. If you were writing this out on a test, this would be the one that you would tend to miss because you wouldn't think about having to say this. I went from saying they were supplementary to saying that they equaled 180 because I can do all my work with equations. I substitute with equations. I use the transitive property with equations. All the equality properties of congruence and equalities, all of those math properties, the algebraic properties that we use with that. Okay, and so I have to go back and say that they're supplementary now, and here's why. because the goal, remember, was to say that P is parallel to R. Now here's why I had to change it back to supplementary. The theorem does not say if same side interior angles equal 180, then lines are parallel. That's not what the theorem says. The theorem says if same side interior angles are supplementary, then lines are parallel. I know it seems like we're splitting hairs over that because they mean the same thing. But we have to use the same verbiage. That's the importance of using good definitions. Is it says it a particular way, and we need to say it in that particular way. Even though they do mean the same thing, we need to use them in the way that they are intended.